In this video, we will discuss how we can implement simple circuits using Verilog HDL. Okay. See, in exam, if you're given an expression like this, first draw the circuit for it. It will be easier for us to write the program. Okay. First, identify the inputs and outputs and the number of gates. Here, A, B, C, and D are the inputs, and Y is the output. Okay. The number of gates we would require for this is 3. There are two AND operations and one OR operation. Uh, we perform AND operation on A and B and C and D, and then we add it. All right. See, this is the circuit for it. Let's consider some values. If A and B, C and D, all of them are 1, then what will be the output? A into B will be 1. 1 into 1 will be 1, and again 1 into 1 would be 1, and 1 plus 1 will be 1. See, when we feed some inputs to A and B, there is some output. Before going it through OR gate, there is a wire here. All right. Let's name this wire as OP1. All right. It will be easier for us to write the program if we name everything. Okay. And for C and D, the output will be OP2. Okay. And let's name the gates as well. Okay. This as G1 and G2 and G3. See, uh, all of them are named. See, the output here is, this is the output. Let's see. 1 into 1 is 1, 1 into 1 is 1, and 1 plus 1 is 1. That's what we see here. This is the output after simulating the program. When we have given inputs 1, 1, 1, 1, the output will be 1. All right. This is the wires we had named as OP1 and OP2. Their value were also 1. All right. That is what it is. So see here you can see I means input and O means output. Let's see the how we write the program. First the structural gate level. In structural gate level, we first mention the variables we use. It's like we declare variables in C, right, or any other programming language. It's the same, nothing else. Then we say what are the inputs and what are the outputs and wires. This all these are keyword input, output, wire, and even these and or. This and keyword performs and operations and stores that value in the output. Okay. First we write the output and then write the inputs for this gate. We had named this gate as G1, G2, G3, right? See, first we perform first and operation. G1, in the G1, A and B are the input and OP1 is the output. That's what we have written here. Uh, we had given the input as 1, 1. So 1 into 1 will be 1 and in OP1, 1 will be stored. Again in gate 2, same thing happens. 1 into 1 is 1 and in OP2, 1 will be stored. All right. Then in this line of code, this is an OR keyword and this is gate 3. All right. 1, 1 was stored in OP1 and OP2. Then again 1 plus 1 will be stored in Y output. That is 1. That's it, nothing else. So in structural gate level, what we should do, first we should name everything in the circuit. All right, inputs, outputs, wires, gates. Then we should start writing the program. First mention the inputs, then outputs, then wires, and then one by one write the inputs and outputs of the gates. All right, that's it, nothing else. Data flow is the easiest. You just need to uh, mention the inputs and outputs first, same as structural gate level, and then use assign keyword and write output is equal to the expression. See, this is an AND operation symbol and this is an OR operation symbol. That's it. A and B or C and D. That's it. Nothing else. This is data flow model. Then coming to behavioral model, it's nothing but basic Boolean algebra. See, observe this expression carefully, okay? For y to be 1, any of these two values should be 1. Either a into b should be 1 or c into d should be 1. Why so? Because in Boolean algebra, anything plus 1 will be 1, alright? That's why. See, even if both these values are 1, then we don't need to care about this value only. That's what we write here. This always at definition or statement is like a for loop in C, nothing else. Uh, See, first this condition will be checked. If A equal to 1 and B equal to 1, Y will be assigned to 1. Or else if this is false, assume that A and B are 0, so this condition will be false. And assume C and D is equal to 1. So 0 plus 1 will be 1, right? That's why we assign Y is equal to 1. If all of these values are 0, then both these condition will be false. Then this condition will be executed and Y will be assigned to 0. Okay, that's it, nothing else. Let's consider some other kind of inputs. Let's assume A as 0, B as 1, C as 0, and D as 1. 0 into 1 is 0, alright. And again C into D, 0 into 1 is 0. 0 plus 0 is 0. Output should be 0. That's here. A is 1, it's reverse. Both are same, okay. One of them is 0, then the output will be 0. That's it, nothing else.